Okay, so now let's find the Cartesian equation for the following parametric curves. So we have x is equal to t cubed minus 6t squared plus 12t minus 8, and then y is equal to 10 minus 5t. Okay, so what we're going to do, we will try to merge the two equations in such a way that the variable t becomes eliminated. So let's try to factor some stuff here. So if you see here, this term is actually a binomial expansion. So this is actually equal to t minus 2 quantity cube. And then whereas here for y, this is y is equal to negative 5 multiplied by t minus 2. Okay? And since we have a common factor here of t minus 2 and y is the simpler expression, then we can rewrite um, this equation by isolating t minus 2, and then we plug into um, to the first equation. So we have t minus 2 is equal to negative y over 5. Okay, so let's plug in. So we have x is equal to negative y over 5 cube. And then let's just simplify. So x is equal to negative y cube over 125. And then just simplify further. So we have 125x plus y cube is equal to 0. And since there's no restriction for t, no, so so we know here that both x and y encompasses the whole real numbers. So and therefore the Cartesian equation is 125x plus y cube is equal to 0, where x and y are real. Okay, so next we have x is equal to negative 5 minus 3 cosine 3t, y is equal to 1 minus sine 3t. Okay, so we have some expressions here involving sine and cosine. Then we can use the Pythagorean identity, cosine squared x plus sine squared x is equal to 1. So let us isolate the trigonometric expressions. So for the first equation, we can isolate cosine 3t. So we have this is equal to x plus 5 all over negative 3. And then for this one, we isolate sine 3t. So we have sine 3t is equal to y minus 1 all over negative 1. Okay, and then just use that identity. So let's plug in. So we have x plus 5 all over 3 squared plus y minus 1 squared is equal to 1. So now let's look at the values of x and y, that will be valid for this equation. So how do we do that? We can go back to the trigonometric expressions. This gives us automatic ranges for cosine and sine. We know them that they are just ranging negative 1 to 1 inclusive. So what we're going to do, so we start there and then we derive x and y. So okay, so let's start. Cosine 3t is between negative 1 to 1 inclusive, and then we add, multiply, or whatever so that we can arrive at this expression. So let's multiply both sides by negative 3. So again, once you multiply a negative number, the direction of the inequality reverses. So when you multiply negative 1 by negative 3, so this becomes a 3, and then this becomes the upper bound, and then 1 times negative 3, so this becomes negative 3, the lower bound. And then we add both sides by negative 5, so we have negative 8 less than or equal to 5 minus 3 cosine 3t less than or equal to negative 2. Okay, so this which is x. So you know that x is negative 8 to negative 2 inclusive. So now let's move on for y. So we have again negative 1 less than or equal to sine 3t less than or equal to 1. And then we multiply both sides, all sides by negative 1. So again, no, this reverses, but there's no change here. Okay, and then add all sides by 1. So we have 0 less than or equal to 1 minus sine 3t less than or equal to 2. Okay, so you know that y is between 0 to 2 inclusive. So therefore, the Cartesian equation is, so again, no, x plus 5 all over 3 squared plus y minus 1 quantity squared is equal to 1, where x is from negative 8 to negative 2 inclusive, and then y is from 0 to 2 inclusive. Okay, so next, so we have x is equal to 3 sine squared t, y is equal to 1 plus cosine t. So again, these are expressions that involve sine and cosine. So let's do again the Pythagorean identity, cosine squared plus sine squared is equal to 1. So let's isolate the trigonometric expressions. So we have sine squared t is equal to x over 3, and then we have cosine t is equal to y minus 1. And then again we plug in, so you get y minus 1 quantity squared plus x over 3 is equal to 1. So just like what we did in B, we're going to restrict the trigonometric expressions, no, into their ranges, and then try to rewrite the expressions so that we can arrive at x and y. Okay, so now we start with sine squared t. Okay, no, so this is between 0 to 1 inclusive, and then just multiply both all sides by 3. So 0 less than or equal to 3 sine squared t less than or equal to 3. So you have x is between 0 to 3 inclusive, and then again cosine t, no, this is between negative 1 to 1 inclusive, and then we just add 1 both sides. So we have 0 less than or equal to 1 plus cosine t less than or equal to 2. So you know that y is between 0 to 2 inclusive. So we have the Cartesian equation is, so y minus 1 quantity squared plus x over 3 is equal to 1, where x is in the interval 0 to 3 inclusive, and y is in the closed interval 0 to 2. Okay, so next, find the equation of the tangent line to the parametric curve described by the equations x is equal to 2 minus 3 cosine t, y is equal to 3 plus 2 sine t at point P, 4 plus 3 square root of 3 over 2, 2. Okay, so what we're going to do first, we want to compute for the t that will produce this point. Okay, so we will just be equating these coordinates to the equations. So let's first start with the x coordinate. So you have x is equal to 2 minus 3 cosine t, and then plug in 4 plus 3 square root of 3 all over 2. So equal to 2 minus 3 cosine t. And then just simplify, we have 4 plus 3 square root of 3 is equal to 4 minus 6 cosine t. And then cancel out the 4, and then divide both sides by negative 6. So you get the cosine t is equal to negative square root of 3 over 2. So let's do that as well with y. So we have 2 is equal to 3 plus 2 sine t. So you get sine t is equal to, so transpose 3 to the other side and then divide by 2. So that's equal to negative 1 over 2. Okay, so since we have here sine t and cosine t, then we again use the interval 0 to 2 pi inclusive. Okay, so here we have both sine and cosine negative, so that means that we're looking for t that is in quote-unquote quadrant 3. So that means that the t we're looking for is between pi to 3 pi over 2. Okay, and then let's do the reference angle. So the reference angle here is pi over 6. So we have pi plus pi over 6. We have 7 pi over 6. Okay. So now, since we're dealing with a tangent line, then we need the slope. So we will be looking for dy over dx. So but before that, we need to show that the curve is smooth. And to show that the curve is smooth, we need to check dx over dt. Now we have 3 sine t. So what we're going to do, so let's just compute for dx dt, dy dt, and then what are the values of t that will make them 0. So dx over dt will be 0 when sine t is equal to 0. So again, at the interval 0 to 2 pi inclusive, so the t that will make this 0 is 0, pi, and 2 pi. And then we have dy over dt, so 2 cosine t. So we have dy over dt is equal to 0 when cosine t is 0. So that occurs when t is pi over 2 or 3 pi over 2. Okay, so to know if the equation is smooth, you need to check that dx over dt and dy over dt are continuous on the interval, and at the same time they are never both 0 on that interval. So yeah, definitely since we know that these are trigonometric expressions, sine and cosine, these two are continuous everywhere, so definitely they should be continuous on the closed interval. And then you also see that the values of t, where dx over dt and dy over dt are equal to 0, are different. All of them are mutually exclusive, so you know that they will never be both 0. Okay, so therefore the parametric curve is smooth in the interval 0 to 2 pi. So now we can proceed. Now we can compute for dy over dx. So that's just dy over dt over dx over dt. So let's plug in. So we have 2 cosine t over 3 sine t. And then, so this is true for all t in the interval, but we need to exclude the values of t that will make dx over dt equal to 0. So these are 0, pi, and 2 pi, so we remove them. So remove 0 and 2 pi, so this becomes an open interval, and then we remove pi. Okay. So to get the slope, we just need to plug in the t that we computed earlier, that's 7 pi over 6. And we can do that because 7 pi over 6 is within this interval. So we have 2 cosine 7 pi over 6 over 3 sine 7 pi over 6. So we know these values. Cosine 7 pi over 6 is negative square root of 3 over 2. And sine 7 pi over 6 is negative 1/2. So these two are just what we computed earlier. So therefore you get a slope of 2 square root of 3 all over 3. Okay, so now we can use these numbers and plug into the point slope form. So let's use y minus 2 and then the slope 2 square root of 3 over 3, and then x minus the x coordinate 4 plus 3 square root of 3 all over 2.